Welcome to Chapter 3. This is Trigonometry, Section 3.1, the tangent ratio. Well, before I get into what is the tangent ratio, I need to talk a little bit about what is trigonometry. Specifically, it's a branch of geometry, geometry being the study of different shapes. But trigonometry, if you were to guess from tri, focusing on the study of triangles. Okay. What does it do? Well, it acts like a bridge. I've got a picture of a bridge. And what it connects or brings together are the sides of a triangle, meaning the lengths, to the angles inside. It establishes the relationship between the two. So let's get right into it. Number one says use common sense to determine the value of x, x being this length here. Well, we have a triangle. It is a right triangle because this is 90 degrees. This angle is given as 45 degrees, and it has a height of 11. Well, I would expect you to know already that all three angles, no matter what type of triangle you have, they have to add up to 180. Okay, so 180 minus 90 minus 45 would give us this angle left over. And that works out to also be 45 degrees. Well, because these two angles are the same, that means this triangle is special. It means that this side is the same length as this side. And I can denote that by putting these little hash marks here. So if this is 11, we have no choice. X must also be 11. Okay, so here I've just deduced from the angles what the length of x has to be. Let's do another one. Here I have, well, it is a similar triangle in that the angles are all the same. So this is also 45 degrees. This triangle is just a slightly blown up version than the first one. Okay, so because these two angles are the same, that means these two lengths are the same. So x must also be 20. Okay, so both of these are right triangles, but specifically they are isosceles triangles. And in general, an isosceles triangle is any triangle, doesn't have to be a right triangle, where two sides, and only two sides, are the same length. Once you've established that, these two angles at the base must also be the same. So that's an isosceles triangle. Number two, use common sense to determine the unknown angle theta, pronounced, well, theta. This is just a letter of the Greek alphabet. And in mathematics, when you see this symbol, typically we're just referring to an angle. So here I have another right triangle, but instead I have 4 and 4 given as these two sides. And I want to determine what this angle has to be. Well, because this is 4 and this is 4, of course those are the same, that tells me I have an isosceles triangle. Therefore, if this is theta, that must also be theta. They have to be the same. Well, remember, all angles of a triangle have to add up to 180 degrees. So if I start subtracting 180 minus 90, that gives me 90 degrees left over. But that 90 degrees has to be split between these two angles equally. Well, the only number that would work is 45. Okay? If this was not 45, it was something else, then theta would have to be something different. Okay, because if you add that to 90, you would get a number other than 180. Let's try another one. Okay, I have a massive triangle by comparison. This is 5,000, that's 5,000. Well, that's isosceles, because those are the same. Therefore, that is the same angle. Okay, so 90 plus theta, that has to be 180, but these are the same. So between 90 degrees, each of them has to be 45. Okay, so not too difficult. Number 3, Why is it not possible to solve for x explicitly? So here I have another right triangle. This is 45. Well, I know that's also 45. So I know all three angles. Therefore, this side have the same length. Well, unfortunately, there's not enough information to go by because, yes, these two sides are the same, but because I don't know what this is, okay, I can't match it with x. So even though I know all the angles, it's still not enough for me to determine what x is. So not enough information. Okay. Number 4, label the triangle. Well, what does it mean by label? Well, I'm just going to introduce some terminology. So if I have a right triangle, and then I choose one angle here just to be theta, these three sides have names. This side, from Pythagoras, you should recognize as the, or no, that's the hypotenuse. So for a right triangle, remember, it is always the longest of the three sides, and it is always directly opposite the 90-degree angle. So this would be C, within the a squared plus b squared equals c squared. Well, these sides have names as well, and they change depending on where theta is. Okay, so if you look where theta is, if you go to the opposite side, we actually label that side as just that, the opposite. Okay, and then this side, the third side, we call that the adjacent. Okay? However, these two sides are interchangeable. Okay, you don't have to write this down. But let's pretend my theta was here and not here. Okay. Well, this would still be the hypotenuse because it's the longest side opposite the 90-degree angle. However, because of this theta now being here, this would be the opposite because it's opposite that angle, which would make this side here the adjacent. Okay. There we go. All right. Well, this video is called the tangent ratio, so let's define what the tangent ratio is. Well, it is a ratio. We define the tangent of angle theta to equal the ratio, so that implies division, of the opposite to the adjacent. So the hypotenuse is not mentioned. Okay? And we write that like this. We say the tangent of angle theta, and we abbreviate tangent with tan. And if you look on your scientific calculator, you should see a tan button somewhere. So we say the tangent of angle theta is equal to the opposite, I'll just abbreviate it, divided by the adjacent. Okay? So when you divide those two numbers by each other and you get an answer, that is what we call the tangent of theta. Okay. So let's do a couple of examples. What is the tangent of 45? Okay, so that means when I have a right triangle and my theta is 45 degrees, what is the ratio of the opposite to the adjacent? Well, if you look up above here at question 2, we have just that. Okay, we had a right triangle, and remember we worked these out to be 45 degrees, and these were the same. Okay, the opposite is 4, and the adjacent is 4. So what is the ratio of 4 to 4? Well, 4 over 4 is just 1. Okay? Well, guess what? Your calculator actually knows that as well. So take out your calculator, hit the tan button, and then type in the number 45, hit the equals button, and it should give you the number 1. Okay? If it does not give you the number 1, most likely your calculator is in the wrong mode. So for this entire chapter, Okay, your calculator should be in degree mode. Okay, and you'll know it's in degree mode if on the display it says D, or maybe it says DEG. That's how you know you're in degree mode. If it says something like R or RAD, rad, okay, that means radian. Okay, that's a different way of measuring angles that you're not responsible for another couple years. So just make sure your calculator is in degree mode. Okay, take the tangent of 45 and it should give you the answer 1. Okay, well, not all right triangles have angles here that are necessarily 45. What if this was 35 degrees? What would the ratio be? Well, that ratio is already programmed into your calculator. It knows. And so just put it into your calculator. So that's what I'm going to do. Oh, my calculator is in radian mode, so I better change it back to degree mode. Tangent of 35 equals, and I get an ugly decimal, so I'm going to go to 4 decimal places. So this is 0.7002 approximately. Okay, so that's the ratio.